Our next guest is Matei Badanoiu, pen tester by day and security researcher by night. He lives by the motto, everything is vulnerable. He found and reported more than 100 zero-day vulnerabilities in softwares by well-known vendors like Oracle, Cisco, or VMware. Today, he will take us on a dive into Java exploitation. Matei, you have the stage.
Well, hello, DefCamp. So, yesterday was great, tomorrow was fabulous. Actually, today is fabulous, tomorrow is the weekend. Of course, it's got to be fabulous. But we have one presentation that will literally end all presentations. Look at the timestamp, it's going to end soon enough. Anyway, let's kick off this presentation. If the display people would be so kind. Perfect. We're live. Anyway, as you can probably see from the text, I am Matthew for the English speaker Badanoiu. The handle is Mal. We'll get to it soon enough. So, what will be the presentation about? As you can see by the catchy name, 5.0 Shades of Java Exploitation. We'll practically be going through 5 types of Java exploitation you would usually find during a pen test. We're taking it from a pen tester's view, a gray box to black box view. We're not going into the code white box to see and create our own gadgets, but we'll get into it soon enough. So, first 2 disclaimers before we begin. As you can see, my opinions are my own. I do not represent my employer today. Only in the good parts I represent my employer. The bad parts are my own. And of course, warning, this presentation may contain traces of humor. And let's start from 0, as any good programmer knows. So, the man behind the shell. This, comically, for context, is the initial picture I sent to DefCamp. Although it has wings, it did not fly past the committee. So, you have my picture on the site. Who am I? I am the man behind the shell. I am Matthew. I have been hacking stuff for 7 years, been professionally hacking stuff for 6 years, and as the delightful presenter at the beginning said, I have had 100 CVs in Oracle with MySQL connectors, WebLogic, and so on, Cisco, and Apache. All of these are remote code execution or local privilege escalations to root, so they were interesting. So, if you do not like my voice, my face, or my sense of humor, all these, actually some of these CVs are on my GitHub, just as plain as it can get. And yes, again, if you're interested, you can find them there. I released them today. Okay, so let's set the scene. You are a pen tester. Yes, you, every one of you. Your client wants you to test a Java application, or more. Usually, it's more. And as time goes, your deadline is yesterday, because that's how time works in a corporate setting. Too long didn't read for this presentation. You'll need 4 things. Deserialization, 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 and you probably guessed it, deserialization. But I promised you 5 things. So let's begin with the thing that is not deserialization. It's the Java Debug wire protocol. You probably heard of it. If not, it's very simple. It's not deserialization. It's if Nmap says you have a Java wire debug protocol, then the engagement is already done. You can get your remote code execution and go home. Unfortunately, as I told you, we'll have CVs as proof of concepts, but Java wire debug protocol is so easy to find that I was not able to find any 0 days with it. And the other ones require too much time to set up. So yeah, but I wouldn't be bringing it here if I didn't find it in the wild or at the client. So I didn't find it in the wild, I find it at the client, a concerning number of times, I might add. And the most well-known example I saw is this PayPal exploitation from 2015. So it's been haunting the internet since. But let's get to the technical part of it. We're not going to go too in-depth into it, but we should know what it does. The debug protocol is a function which is standard to Java. It's a built-in. It's practically debugging over a TCP protocol with packets. And what we're interested in is to hook or to put a breakpoint on specific Java functions and replace them with our Java long runtime to run arbitrary code. So we will, in this case, misconfigure a Druid Apache. The Druid Apache, for disclaimer reasons, is not vulnerable by default. We have made it vulnerable in order to prove a point. You nmap it. Again, nmap, the pen tester's best tool, or the security researcher's best friend. And we can use this lovely GitHub repository with JDWP shellifier in order to get our shell. There's only one technical thing you need to know about it. The rest is straightforward. So you need to hook a Java function. You don't know what the code is behind it. We consider it full black box. We're interested in finding a Java function that is very commonly used in order to hook it, because the exploit doesn't just run by itself. It waits for the function to be hooked. So usually by default, we have this socket accept, which is hooked. It's 50-50 chance it might work. For increasing your chances, string functions are your best friend. So things like string length, string equals, string empty, usually they're called by default in multiple contexts. So they usually run just as fast as you run the exploit. Index off is also a recommendation of the JWP shellifier or hack tricks, but it may take a while. It has 99% success rate, but it will take a bit more. Other useful function, in case there is a mad developer that doesn't use string in his programs, you might use object equals or URL open connect, in case you're dealing with an HTTP server. If not, then the open connect is not so relevant. So this is how the exploit should look like. At some point in time, let's see, yep. So it should stop here. It's waiting for the event Java string index off to execute itself, and it should remain blocked until the function executes itself. When the function does execute itself, it will replace the index off with our runtime and will execute our bash command. We're in a Linux environment, we're bona fide hackers. So yes, bash commands all the way. But you're probably wondering, what in the name of what is this command? I'm not doing it for obfuscation purposes. This bash equal base64, something ungodly is happening there. And let's figure out why I need to use it, because it's not just using it for obfuscation's sake. So there are particularities in Java lang runtime. So usually when you see a space, Java lang runtime exec will try to delimit everything by spaces. So something like LSLA works because it takes the LA as a string and it passes the flag as it should. The ls my directory, on the other hand, does not work as it should. It's taking my and directory as separate values. And it'll tell you, yes, ls does not know my, it does not know directory. Good luck. Anyway, we're interested in reverse shells usually. So our reverse shells with lower than greater than the pipes that usually send our input from one place to another do not work. They're string literals in this case. So we need something like a bash C encoding with echo base64 decode and to pipe them in another bash in order for it to work at all. And yeah, that's the fun of dealing with Java lang runtime. But it works. So if you don't have a bash environment, God help you. But yeah, usually you have wget or curl, which you can get your file locally and then run it with bash separately. If you have PowerShell, then again, you can base64 encode it and you just have the enc flag or the encode command flag. Just two things to keep in mind. Bash and Linux use UTF-8 and PowerShell and Windows use UTF-16 lesser endian? I can't remember. Anyway, if you encode them as it should, it works. But, of course, as any problem arises, someone creates a website to deal with it. And we have this Jackson's website, which you can just write the command there, and it will give you the encoded command straight off the bat, and it works. If you have client-sensitive IPs and the rest, again, disclaimer, do not use a public website. Code it yourself. Encode it yourself. So, we got to the deserialization part. We have 3 more deserializations to go. So this is just a sample of all the possible deserialization vectors we can have in a environment. And again, this is not a complete list. If you want a complete list with CVs and proof of concepts and everything, then you have Gerdog's GitHub, which I highly recommend. So I'm sure someone at Oracle went, when they invented serialization, serialized everything. And I mean everything. But the cost was, of course, everything. In 2015, Fruhoff, I think, created YSO serial, and the rest is history. We're getting shells left and right due to Java serializations all the time. So let's get, if you're not familiar with the subject, then I created a basic hands-on laboratory and PDF at this location here from Hack Like a Red for a different conference, but you can use the information here and get some hands-on knowledge if you're new to it. If not, then let's get to the basics of it. Serialization, of course, you're transforming cubes into data. You have a object which has some attributes which you want to keep. Let's say the cube's length, size, density, its name. Yes, the cube's name is John. Deal with it. And you're interested in keeping all these functions and values that are associated with it as fully interactive. So you will transform it into a binary code, store it in files, send it over TCP, and then you're interested, of course, using deserialization to create a fully interactable Java object with underscore for interactable, because that's where things get juicy. So we have two types of deserialization. Usually the most common ones are ACED, the binary type, but we also have other custom marshalling, and we'll start with the other custom marshalling. So you probably heard of these, YAML, XML, JSON. They are text-based, they are normal, they are everyday occurrences in your life. But in Java, they are your worst sin if they're not properly secured. So we have another very nice GitHub Marshall sec, which has payloads for all these non-WISO serial vulnerabilities. And let's start with the CVs. So this was a CV from 2021, a YAML deserialization. So if you thought deserialization was hardcore, it was tough, it was complex, no, these 3 lines of code are deserialization in YAML. This is all you need to know. You do need to compile some Javas in the background, but then again, here comes YAML payload from Artsploit to the rescue. You just need to replace a bit of Java with your code, and then everything is smashing. So how does it work? In the case of Magnolia, you just upload the YAML file anywhere on the page, a snake.yaml file. It takes from the extension what you want the format to be. It parses it. It will make a few callbacks for the JavaScript engine factory, which contains a bit of metadata for what type of class and from where you want to load it. In this case, our awesome script engine factory, which will send us back a reverse shell. So again, we just started the presentation and we already have 2 remote code executions. Now, let's go back to the binary serialization. This is your normal serialization. You have the AC. So it usually begins with the hex value ACED0005. You'll usually find it as base64 encoding or gzip encoding, or the server will be kind enough to tell you, yes, the content of the page that was returned is X Java serial whatever. Anyway, as mentioned before, we have the most common, the most famous tool on the internet, I think, WISO serial, when it comes to Java exploitation at least. Everybody knows the first GitHub link, but the second GitHub link is just as nice, if you know what you're doing, the new gadgets, where you find gadgets which are being tested and will be integrated into the main product. And yes, pro tip, if URL DNS does not work, the payload of type URL DNS, then probably the other payloads will not deserialize. So we continue with a research into a CV, which is not mine, surprisingly. HSQL, back in the day, had allowed you to call static Java functions from anywhere, as long as they were loaded in the program. So you can do something simple as this, just to get the Java version and runtime environment. So it's an information disclosure. Good. We finished our work. No, we did not. So as the NFD will tell you, it's a 9.8 critical vulnerability. And information disclosure is not 9.8 last time I checked. So let's see how we can get remote code execution. In 2019, and this is how I stumbled upon the idea that would later become the CV, there was a exploitation in F5 by Mikhail from PT Storm. In his case, anyway, it inspired me to look into Solera because I was exploiting it at the time and see that they were advertising their JDBK stream and were using HSQL to do the thing. So this is the payload that resulted in, that the resource resulted in. But let's take it step by step because it's rather big. So first, we'll generate with WISO serial our common collection 6 payload, or our serialized payload. We will, and yes, we will encode it in base64 or hex. It depends, whatever you want. So then we will look into our functions. It was a, it's a white box. It's an open source application, so it was a white box. We will look for a sink that will lead us to the object input stream. and the read object. This is what creates deserialization in the background. So the deserialize function is our thing that will take our input, which we control, and will go to the read object vulnerable function. Because there are no object whitelists, then this will again be built into an interactable object, which can result in remote code execution. We again used, if we look back, we used base64 in order to encode our payload, because deserialize does not accept a string, it accepts a byte array. So we need a way to transform our string into a byte array. So we'll be using log4j, which you probably heard of log4shell, but anyway, log4j, as it should be intended, is a logging interface that should handle most type of conversion, hex, base64, and so on and so forth. So we're going to be using it. So these two should be usually enough for deserialization. But in this case, because Apache Commons is so commonly exploited, the unsafe, enable unsafe serialization flag needs to be set to true by the application, or else it does not happen. So this is an inbuilt security measure. How do we do this? Well, again, we call static functions. We can just go, yeah, set property. Why bypass something when you can just remove the security feature entirely? So we're going to enable our unsafe deserialization to true, and guess what? We have remote code execution. 3 different types of remote code execution, to be exact. And this is how it should look like from the attacker's point of view. You insert the stream, and you get the reverse shell. 3 reverse shells so far, if anyone's counting. But let's go into a tangent. We saw the error message, like, yeah, we're not going to allow you to do deserialization because it's unsafe and you need to enable it yourself, which we did. So the error message is in Java with deserialization. There's one rule. Even your success will result in a failure, or in an error, better said. Never trust the output of the tools, and we'll see immediately why. So the most common types of errors, which is a success error in this case, is the URL DNS. You can see the number from here underlined with red. So this number is generated if your object is successfully created. That number should be randomly generated and should change from error to error. And that means that our object was successfully created and a DNS connection was made back. It's not remote code execution, but it gets the job done. Again, you identify the serialization fast this way. If you're looking for other common errors that tell you that the exploit did not work, you'll have the class not found exception, which is the most common one. So as a top-level view, you can think about deserialization in Java as a gadget within a gadget within a gadget, a matryoshka doll, if you want, of Java classes. If one of the classes in the chain does not exist, then, sorry, your exploit is not going to work. And yes, class not found will tell you that your exploit surely does not work. You need to either forcefully include a jar or you're out of luck. And then we also have the invalid class exception from the point of view from the serial UID. This means that the class exists, but it's a different serialized version. Usually the serial version changes when you make a major change. Let's say you have function A that takes a string at one point in time, and then the developer changes it to include 2 strings. In order to not have problems between the intercompatibility of those 2, you're going to give a different serial UID to each. So you can tell it, yes, the old version accepts just 1 string. You're using the new version that takes 2 strings. Sorry, you need to downgrade or you need to upgrade. And usually you change the... so what's interesting with Clojure is that it uses a Javax type of class. If you know, Java and Javax are built-ins to Java. So that means that the Java version itself you are using is not compatible with the server's Java version. If it's something else than Javax, then you need to change the packet that you're using. So for example, if it was a org Clojure something, then you need to change the version of Clojure. You usually can find them online on GitHub. You have the serial UID statically coded in the code. And of course, you also have the false positive, which are the best kind of error. It tells you, the tool usually tells you, nah, mate, it did not work, and you still get back a reverse shell. So I ain't even mad. Okay. So the lightweight directory access protocol, you probably heard about it. It's in LDAP, it's in Kerberos environments. Usually that one is not vulnerable because it's coded in C, C#, so on and so forth. But someone at Java decided at some point in time that we should include the Java objects in it. Serialized objects, complex remote code bases. Yes, we're going to include all of these in the Java implementation of LDAP. And these are the most common types of attack, either deserialization on the client side or code-based reflection on the server side. And yeah, the most notable GitHub repositories are the Rogue JNDI, which has some gadgets from Groovy and such and so forth, which is very nice. And we have the JNDI exploit kit, which also contains deserialization gadgets, which you can either add custom gadgets or you can specify, yes, I want you to send a object of type common collections to the server when it makes a LDAP request. And again, let's start with the CVs. So in Apache Nifi, we have an LDAP deserialization. One of the factories, the JNDI factories, accepts LDAP lookup. It has a, you can specify the class as a LDAP CTX factory. We won't get into detail with it. And as I told you previously, we need to forcibly include the closure jar in it, or else it does not know the functions behind the class. Thankfully, it comes bundled and locally available, so if you know the path, you know where the classes will be for the deserialization gadget to happen. So the complex part with this is that you need to change the version of closure. The default version of closure is 1.8. Again, because the serial UID changed and the implementation of the function changed, you need to switch it to a newer version 1.11, the one used by the Nifi server. But then again, if everything goes as planned, we have reverse shell, we have remote code execution, we have a closure do exploit through LDAP. And just as a bonus, again, I told you code-based attacks exist. So I was looking for this presentation, because this was not planned, this was a last-minute addition. There's a iSafeBlue, I do not know how to pronounce the Chinese guy of the author, I'm sorry, that has included a that has researched the topic in 2022, I think, and has a very nice presentation at the following link. Practically, we are interested in setting the parameter of trust URL codebase to true. And as we discussed previously in the exploit from Solar, we have that static function of set properties. We have also the static function of do lookup, which we can give it a LDAP or an RMI source. And this is how it should look like. I do not know why it doesn't work in Solar, but it works in the default HSQL binary and actually application, and that works for me. So again, I think 5 remote code executions so far. Anyway, I lost count. Now let's go into the more esoteric types of Java-specific applications. So the remote method invocation in Java, or the RMI for short, it does not support authentication. So this is the main feature. Sorry, I mean problem. It's a feature for us attackers, but it's a problem for everyone else. So although we have no authentication, why did it not set the internet on fire? It did in 2015 and 2016, but why did it not set the internet on fire as log4j deserialization exploitation? Well, it's mostly due to the fact that RMI does not tell you what function it supports. The main idea behind it is that you have a client that knows stub functions, meaning just you know the name and you know the arguments that need to be passed to the server, but you do not know anything about the implementation of the function. The server needs to give you a result, and that's all. And this is a graphical image, a nice graphical image for graphical help. But the idea behind the RMI attack, there are actually 2 different ideas. This one is a bit obsolete in 2023, but if you are testing an old software, it still works. So there are 3 protocol level components of RMI: the activators, the distributed garbage collectors, and the RMI registries, which you can just send directly serialized objects to it, and it will be deserialized. But this was in the past. Unfortunately, after JEP 290 and also JEP 407, these aren't available anymore. But then again, application level deserialization is always the way to go. So for application level deserialization, we need a valid RMI function. Unfortunately, as I told you, they are not advertised by the RMI application. You need to specifically brute force them. You need to know the type of value that will be returned by the function. So you don't need to know only the name of the function. You need to know the type of value that will be returned, and also all the arguments in the function. It won't give you half-truths like, yes, this function exists, but it doesn't have the arguments. No, if you don't have the correct signature for it, you get nothing back, and you don't know if you have a vulnerable function behind it. If you have something like execute, you can just call it directly and execute your own code. If you have something more complex like, let's say, login, we'll see short enough how we can exploit that. So besides brute forcing it, if you have access to the Java jar, then you can use GDGUI or a decompiler in order to find what functions are exposed remotely. And usually that's the best way to go if you have the code. If it's a black box, then again, brute forcing is the way. So we're looking for interesting functions. We'll either find something, not all functions are interesting, although they are interesting in the word of, yes, they give us useful information back. Let's say get version, which gets the version of Java. It does not give us potential for remote code execution or deserialization. Again, we have also functions that take Java private, such as int, double, char, boolean, again, cannot be used for deserialization. Let's say something like delete row ID. If you have something in SQL like this, you can just delete the whole SQL database, but you're not going to obtain remote code execution. So what are the functions we're interested in? Functions need to have non-Java primitive arguments. Again, Java primitives, int, double, char, boolean, these are primitives. String, the most used Java type of object, is not a primitive. And you can see where I'm going with this. So again, as I mentioned, back in the days of 2016 when deserialization dinosaurs were roaming the plains of Java, it was simple. You just say, yes, attack the distributed garbage collector and deserialization would happen by magic. But unfortunately, in 2016 and later on with 2021, I think, with 2 JEP improvements, the 290 and 407, those deserialization vectors are gone. But again, application level deserialization still works and is great. So there are very nice blog posts on this subject if you want to research them yourself from Hans Martin. And also the tools which we'll be mainly using to exploit Java these days are the remote method guesser, which guesses your objects, your methods, and also allows you to directly serve them as serialized objects. And let's go for, again, this is a CV of mine. It's not old enough to drink. As you can see, it doesn't have an ID. Actually, I received it yesterday, but I didn't have time to modify the slides. So let's look what the RMI deserialization looks like. Again, nmap is our friend. It tells us, yeah, our process initiator implements a class of this type. If you have the jar, then again, you can look through the jar in order to see what functions are implemented by that type. Or if it's an open source subject, then, if it's an open source project, then you can look through GitHub and just look up the look up the functions online. Also, another nice thing, sometimes the class path is told by the RMI listing tool. So if we look there, we'll see classes that we'll see jars that may contain classes that can be deserialized. So this is how it looks like if you decompile the code. Again, if in the case of LOX jar from the LO Digital Software, we have the function register process target, which returns a void, which is interesting from the point of view of the signature, and our non-primitive object process target, which will insert our Java deserialized payload into. The whole string for the RMG jar looks something like this. And of course, the application is running as NT system, because if you have something vulnerable, why should the attacker also bother to elevate his privileges? Well, it's a Windows environment. Even if it's running as a service user, you can just God potato it and your system anyway, so that wouldn't have helped them. And we also have another RMI deserialization. This was from the point of you, the attacker, are the client and you're attacking a server. Now let's see if a server connects back to us. Actually, a client connects back to us as us, the malicious server. So again, we go for NIFI. Although they patched it once, there is a bypass. So you can bypass it and just give remote. You can set up your own RMI server. You point it towards your server, and then you give it, let's say, again, closure 2, which worked previously. From the LDAP point of view, you can give it as an RMI object as well. And it should look like this. You're waiting for a remote connection from the client, which you receive, and you will execute a ncat, a reverse shell command, whatever you want, and you get another reverse shell. And this would be reverse, this would be remote code execution number 7, I think. I lost count as well. And the last topic of our presentation is the Java management extension. So if RMI was bad, the JMX with no authentication is worse. So you have def by mlets. If the second word does not mean anything to you, the first word should have a gut reaction associated with it. So def. It's bad. It's very, very bad. Again, even authentication does not save you because the JMX is a extension over existing RMI protocols. You can make RMI exploits before even authenticating to the JMX components. But then again, mbeans are listed, so you don't have the same problem as brute forcing function after function with valid function signatures in order to find what you can call and what you cannot call. They are straight up listed to you. And like RMI, we can inject serialized objects in the arguments. So the tool that was most commonly used, I think, since this year it was discontinued. Not exactly discontinued, but archived and not modified anymore. The latest tool is Bean Shooter. Both of these tools are very nice. The mjet tool has a built-in password into the mbeans you are installing. So from a pen test point of view and security point of view when you're testing, such as if you manage to successfully exploit the vulnerability, you don't let the mbean be called by a malicious attacker that may be in the network unless they have the password. So that's very nice with mjet. For the rest, for deserialization, I recommend Bean Shooter. And let's go for Apache JMX. They have made a misconfiguration in it. And yes, while I was writing this presentation, I found another 0 day in Apache James. I was like, I need to finish this presentation, but ooh, 0 day. So yeah, that's my life. So these are the only two functions you need to know for mjet. If no authentication is present, then you need to use the first function. This is the server that hosts the RMI, and this is the port that the RMI is listening on. You install the malicious mbean from a remote target, let's say HTTP. You can also have FTP, or if you don't have remote connection and you have access to the local server, you can just specify file 2 points and it will be loaded from you need to upload the specific jar online, but that's also a possibility if you don't have reverse connection back to you. If the first command was successful, then you just shell into it and you have remote code execution. And of course, Apache James is a mail server that needs to listen on 25, so most of the time it runs as root because 25 is a privileged port. And of course, if one problem in James wasn't enough, we also have the deserialization vector, the common utils. By default, mjet, if not, you can specify JMX password and JMX username. But again, mlets only work if you do not have authentication enabled. If authentication is enabled in JMX, then you need to specifically configure mlets to be installed. If not, then by default they are turned off. So even if you have the username and password for the admin user in JMX, you are not able to use the mlet attack. So how would we exploit that? Well, we either find interesting functions, or again, we look for good old deserialization to the rescue. Deserialization is also nice because if you don't have a reverse connection back to you, if this works, then you execute code directly. So you don't need to grab from HTTP the mbean and so on and so forth. So this is how the exploit would look like. You set up a server. Actually, you don't even set up the server. You connect to the RMI server. You give it the serialized payload. And if everything goes well, then you get back remote code execution. And woohoo, we are done. So yes, I think you're more relieved than me that this presentation is over. But if you have questions, then I potentially have answers. I don't know. I don't guarantee anything.
All right. Thank you so much, Matei. All right. Do we have any questions from the audience? All right. Thank you so much for everything.
Well, thank you for your attendance. Have a nice night.
And thank you all for joining us this year at DefCamp number 13. The award ceremony just started on track 1, so we hope to see you there. Enjoy your day.